Assalamualaikum and hi everyone. Today I'll be talking about topic 1.5 DNA and RNA molecules and 2.5 cell transport. First, I'll be talking about topic 1.5 DNA and RNA molecules. There are three structures of a nucleotide, which is pentose sugar, nitrogenous base and phosphate group. There are two types of pentose sugar, which is deoxyribose and ribose. Deoxyribose is in DNA and ribose is in RNA. There are two types of nitrogenous base, which is pyrimidine and purine. There are cytosine, uracil and thymine. Under pyrimidine, do note that uracil is only in RNA and thymine is only in DNA. Under purine, we have guanine and adenine. There is also Chagas rules to figure out how the four bases match up in pairs. And you see that adenine will always pair with thymine and guanine will always pair with cytosine. Phosphate group. Its function is to provide structural support to the DNA. DNA structure based on Watson and Crick model. It says that a DNA consists of two polynucleotide chains. Both chains are twisted to form a double helix. Each chain is made out of nucleotides which are joined together by a phosphodiester bond. The chains are anti-parallel, meaning one strand will start from 5' to 3' end and the other one will start from 3' to 5' end. One strand will end with a 3' hydroxy group and the other one will end with a 5' phosphate group. Each strand is made out of deoxyribose and phosphate group repeating to form sugar-phosphate backbone. The two backbones are on the outside, meanwhile nitrogenous base are paired inside the helix. Both chains are held together by hydrogen bonds between the complementary base pair. Next, structure of RNA. RNA is a single-stranded polynucleotide. It is made up of ribose as its pentose sugar, guanine, adenine, cytosine and uracil as its nitrogenous base. It also has phosphate group and it is mainly found in cytoplasm and nucleus. Types of RNA and its function. The first one is messenger RNA or mRNA. It carries genetic information copied from DNA to the ribosome. It also acts as a template for protein synthesis. Next, ribosomal RNA or rRNA. It forms ribosomal subunits together with a protein. It is also involved in protein synthesis. Transfer RNA or tRNA. It transfers specific amino acids to ribosome during protein synthesis. Next, cell transport. Passive transport is the movement of substance from higher concentration to lower concentration region or movement of a substance down a concentration gradient across a selectively permeable membrane without using energy. The first one is simple diffusion. It is net movement of particles from high concentration to a lower concentration region or down a concentration gradient. It doesn't use energy or any transport protein. The process will continue until the amount of particles outside and inside the cell are the same. Facilitated diffusion is a movement of substance from a higher concentration to lower concentration across plasma membrane. It doesn't use energy, but it is with the help of a transport protein. It involves ions and polar molecules of water-soluble molecules across membrane. There are two transport proteins involved in facilitated diffusion, which is channel protein and carrier protein. Next, osmosis is the movement of water molecules from higher water potential to lower water potential region through a selectively permeable membrane. It doesn't use energy and it can be quantified by using water potential, which allows us to calculate which way water will move and how fast. Water potential is the tendency of free water molecules to leave a particular system. It is represented by psi and measured in kilopascal. Water potential of a pure water is 0 and the highest value of water potential is 0, meaning that when we add solute, it will lower the water potential. All lower water potential will have negative values. Solute potential, it is the ability of dissolved substance or solute to lower the value of water potential. The concentration of dissolved substance inside the cell will determine the solute potential. Remember that the value will always be negative, and a solution with less solute than the other has higher water potential. Next, there are three types of solution, which is hypotonic, hypertonic, and isotonic. So, pressure potential is the pressure that the cell will develop resisting the hydrostatic pressure. The pressure potential is usually positive. Tonicity of solution. Hypotonic contain less solute and high water potential. Isotonic, the amount of solute and water potential is the same. Hypertonic, it has more solute and low water potential. Osmosis effect on plant cells and animal cells is the same. It's just that the name of the effects differ. You can pause in order to read through each slide. Next, active transport is a movement of ions or molecules across selectively permeable membrane against a concentration gradient. It is with the help of energy, and it involves transport protein. We will learn about sodium-potassium pump. Sodium will bind to the protein because at this shape, the affinity for sodium is high. The binding of sodium will stimulate the phosphorylation of protein, which causes the protein to change its conformation, thus releasing the sodium. The new shape, it has a high affinity for potassium, which allows it to bind to the protein and trigger the release of phosphate group. With the release of the phosphate group, the protein will return to its original conformation, which has lower affinity for potassium, thus allowing the potassium to be released into the cell, and the cycle will repeat. Next, bulk transport. Bulk transport is a process in which large molecules cross the membrane in bulk packages in vesicles. It requires energy. There are two types of bulk transport, which is endocytosis and exocytosis. Endocytosis allows large molecules to be taken into the cells. There are two types of it, which is phagocytosis and pinocytosis. Phagocytosis, or known as cell eating, it is a process in which large solid particles is taken into the cell. Next, pinocytosis, or known as cell drinking, a process in which dissolved solutes or extracellular fluids are taken into the cell. Lastly, exocytosis. Exocytosis provides a means by which large molecules are released from the cells. For example, secretion of extracellular enzymes, hormones, and antibodies, and removal of waste are the product of digestion from phagocytosis. And that's all from me. Thank you for watching.